Good afternoon, everyone. This is Ranger Jake here in Yellowstone National Park. I want to thank you for joining the next installment of our 150th virtual video series. And today we're in the Mammoth area. We're out amongst the sage. Between Ann and myself, we have this tripod, scientific-looking thing. It's basically got a whole bunch of monitoring equipment off it, but we're standing out here because today we're going to be talking about the past, present, and future of climate change in Yellowstone. And I mentioned Ann Rodman has joined us today. She's been in the Yellowstone area since 1988. She's been in her current position as the GIS manager, so she does all the computer mapping of the park. She's been doing that for the last 25 years. She started thinking about climate change in Yellowstone and what we might be doing for the last 12 years, and it sounds like you've been collecting data on that for the last 6 years.
Something like that, yeah.
All right. So with that, I'm going to go ahead and jump behind the camera, and we'll let you take it away. Thanks for joining us, Ann.
All right, thanks, Jake. So climate change isn't something that, just started happening recently. I mean, this area, if you're looking around, say 13,000 years ago, was buried in thousands of feet of ice. And when that melted, basically it was ground zero for kind of the development of the ecology that we see here today. And that was driven primarily by a warming climate and different types of vegetation moving into the area and responding to that climate signal. Now you jump forward up until, say, the last 100 years, and as it's been on the news and as everyone is pretty much aware, the climate's warming a lot faster than it had currently. In fact, it's probably warming faster than it has in the last 20,000 years. And so what we want to talk about today is some of the consequences, some of what we're finding and some of the consequences of that really increased rate of warming and what that might mean to Yellowstone.
So, you mentioned 13,000 years ago we're under ice. How are you able to figure out what the climate was like, that long ago?
Yeah, that's a good question. There's a scientists called paleoecologists, and they study that, and they look at sediments in lakes or buried in the ground charcoal pieces, and they find pollen grains, and they can rebuild a story of what trees, what plants were here over different periods of time when we had big fires. And from that, they put together kind of a story about the past climate. And that's kind of how we know that right after the ice melted, it was more like a tundra environment. Then we had cold-tolerant trees moved in, like Engelmann spruce and subalpine fir, whitebark pine. And then, maybe 9,000 years ago, lodgepole made its appearance, and then Doug fir came in a lot later in the lower elevations. And that process happened over thousands and thousands of years. And the story, the difference now is not the magnitude, but the rate of the change we're seeing in temperature changes.
Well, and how are we, how far back have we been collecting data, climate data, not through sediments, like through weather stations and things like that?
Yeah, well, we just happen in the park to have the Mammoth Weather Station up at park headquarters, which is the oldest operating weather station in the state of Wyoming. And that started collecting data at the end of the late 1800s.
Oh, wow.
And there was a missing data there in the middle, but we've been collecting data there every morning at 8 o'clock for the last 100 years or so, 100 years or so, yeah.
And so with the 100 years worth of weather data, I mean, what sort of things are we noticing now? Like, when you're talking about the rate of change versus the sediment stuff, what are you noticing?
I mean, it's getting warmer. There's no way around that. And that increase in temperature is driving changes in the length of the growing season. It's getting longer. It's driving things like, well, here, I'll start over again. So an increase in temperature and increasing at a rapid rate means that places that used to, say in the park, go below freezing. We're finding some places in the park have a month or even 2 months fewer days in a year that go below freezing.
2 months?
Yeah, in some places.
Wow.
The mid-elevations in the park are the ones that are being affected the most, or we're seeing that change the most. And that's important because there's, when water freezes, it drives other interactions. And losing that many days below freezing, I mean, I don't know the effect. I don't know that any of us know the effect. We just know that we're seeing a big change.
Well, and I mean, this is, a weather event, but this year, the main reason of the flood was because we had a late snow season, and then basically the rained on top of that, and that basically all flash flooded. So it seems like, again, that's a weather event, but I mean, that's an extreme example of how water in the mountains can affect lower elevations.
Yeah, that it's absolutely true. There were two unusual events that coincided with peak runoff, and that's why we saw what we saw with kind of unprecedented over-the-top floods in June. But things like rain events that would be more extreme, everything we are learning we would expect more of those in the future. Warmer temperatures hold more moisture in the air, and so these violent rain events with more water is what we'd expect to see going forward. What was unusual is that late season snow. In fact, we went into this year really low water. In fact, we were much more worried about having too low water in the streams. We had a record low water last year, and we came in even lower this spring than we did last year. And so the late season snow, what we don't have a lot of experience with are rain on snow events, and that is a lot of what led to the issue with the flooding. When you have snow and it's warm and it's holding a lot of moisture, and then you have a lot of rain on it, it melts really quickly. And in fact, inches of snow, when that rain came, not only was it a lot of rain, that snow melted incredibly quickly, and the combination of those two is what dumped so much water into the drainages. And other parts of the country do experience those, but that is not common at all for us. But going into the future, this increasing temperatures, one of the effects of that is going to be lower snow, but more rain on snow events. So it's definitely something we're paying attention to, and especially after the flood, for sure.
Well, and so as someone who is a part of this program, you're collecting the data. Is it data for scientific's sake? I mean, what do we do with the information that we collect? Is it helping management decisions? I mean, what do we do with all this information?
Yeah, there's a couple of things. Some of it is, you have scientific studies that you try to take careful measurements to really understand what's going on. So some of the collecting of the data is for that purpose. But really what it's telling us is that the same thing is happening in Yellowstone, that's happening all over the whole greater Yellowstone area, that's happening over the whole western US, and really over the whole world. These increasing temperatures are driving all kinds of changes at a rate that we've never seen before. And it's important for us to collect the data. It's important for us to feel confident about what's happening and the trends that are happening. But really, the biggest benefit I can have to the park is trying to think about what that means and anticipate how that might affect both resources and operations in the park, and work with park staff and management to translate, to really think ahead about what kind of effects that'll have. I mean, the recent flood is the perfect example. Where is our infrastructure vulnerable? If we're going to have hotter, drier conditions in the summer that are going to lead to more wildfires and more and in some predictions are we're going to have conditions like 1988, which was very unusual at the time. We're going to start having those every 10 years or so, or even more common. It doesn't mean we'll have fires that big, but we will at some point when you have the conditions. If we get lightning and wind, well, you know, and so how do we prepare for big fires like they're seeing in California? And which of our infrastructure is vulnerable to that? And how do we think ahead about when we rebuild things, making it less vulnerable to those conditions? Our roads, the floods we just had were huge, and I wouldn't expect floods of that magnitude to be common at all. But if we get a late season snowpack, because we'll continue to get snow and we'll continue to get some in the late season, and then we have a really warm spring and it melts really fast, that water is obviously going to go into the drainages, and we will have more floods. There's no question about it. Maybe one bright side to the floods we had in June is we know where our roads are vulnerable, at least in the north part of the park. And I'm sure we're thinking about where they're vulnerable in the whole rest of the park, because we were just lucky that what happened just in the north. I mean, the same thing could happen anywhere in the park. And we have infrastructure that's pretty important all over. So this whole idea of how the changes are going to affect the park is not new, but it's new for people to think about. People in this park know their jobs. They're really good at what they do. But we're used to looking in the past to look at the range of variability to think about what's going to happen in the future. And what's really somewhat frightening about what's happening now is it's not just that things have changed and they've plateaued and we're in a new normal. It's that things have changed and they're going to continue to change. And in fact, all evidence is it's going to continue to change at an increased rate. And that's something we're not used to. We're not used to managing, not only not looking in the past, but looking in the future about things that haven't happened yet and things that maybe would be unusual in the past that in the future will become more common. But incorporating that into our thinking, and the low-hanging fruit is probably our infrastructure. It's easier for an engineer to think about building a bigger culvert to hold more water. But what do you think about predator-prey interactions out on the northern range and how that might change? And if we have fires, and fires are big change agents. Large fires are going to change the vegetation communities in the park. And as the climate change, we're going to have different vegetation growing back after those fires. And what kind of wildlife are those new vegetation communities going to support?
Well, and I mean, another thing too is I remember we think about the resources of the park, but then that also bleeds into how people are able to interact with those resources and what it means as like a visitor to come and do the things that we're used to doing. I mean, last summer, I remember, didn't we closed fishing for a little while because of how low the streams were and how hot the water was, right?
Right. And those, that's really true. And that comes back to when I meant, like, how do we get the information about what we expect to be happening, or what events we think might happen or become more common, and how do we integrate that into park management? And managing the resources is a great example. Yeah, if we have a lower snowpack, and not necessarily less water, but less water falling as snow, this place is designed around storing large amounts of snow over the winter and slowly releasing it in the spring and the summer, which means that not only is there a water supply to keep the streams full, they're supplied with really cold water to keep the streams cold. And as that changes, the more the water is released during the winter or early spring, and we don't have that influx of cold water later in the summer. We have lower streams, just like we had a year ago, and warm summer temperatures, which is inevitable. That's going to happen. Those rivers are going to be warmer and hotter, and they won't support the cold water fisheries that the park's famous for, that we've been managing for. And one of the thoughts is, Well, there are higher elevation places that are going to have colder water longer. And the fisheries groups are already thinking about where those places are and where they can stock or add trout to the higher elevation places where that habitat will be able to sustain those fisheries longer. And that's an example exactly of how to think about these effects and how we might mitigate some of the bad outcomes.
Yeah. And so, you mentioned that what we're seeing in Yellowstone is happening throughout the entire Yellowstone, the greater Yellowstone ecosystem and beyond. The data that you're collecting, like, are we part of like a bigger monitoring network, or does this data flow into a bigger data set? Or
yeah, we're really lucky. We're in the center of this really big the greater Yellowstone ecosystem. We're surrounded by protected areas and other land management agencies, and we work together through the Greater Yellowstone Coordinating Committee. It's the group of the federal land managers in this large area, and we have committees of people that coordinate on climate change. We talk about it. We talk about the effects. We share success stories and failures across boundaries. Climate change isn't obviously not happening just to Yellowstone. It's affecting these same resources all across this ecosystem. And if we're going to be effective, we really have to think about these resources in the much larger sense, in the greater Yellowstone area sense, because Yellowstone's going to be hotter and drier and warmer. It's just going to be. And a lot of these animals that need colder habitats, they're going to migrate to those places in this ecosystem. And it's really important that as land management agencies, the Forest Service, the BLM, us, Fish and Wildlife Service, we coordinate and talk about what we think is going to happen and coordinate and cooperate across boundaries on these issues. And it's not easy, actually.
Yeah.
And it's a big challenge, and there isn't a book out there about how to do this. And so this is all learn as you go, and then share what you've learned with the other people that are doing similar things.
So to wrap up these talks, I usually ask like an anecdote. My personal anecdote about climate change is I moved here 6 years ago, and I could get through the summers without air conditioning, but the last 2 years we cracked down and bought an air conditioner. I'm just wondering, as someone who's been here for since 1988 and someone who's actively paying attention to the climate, if there's any anecdotes that you've noticed just in say 30 years that indicate this, that you're noticing the warming climate.
Oh, for sure. The one you just mentioned is, we used to be able to count on it getting cold at night, and I live down in Gardner, and I feel bad. I have friends that live in much warmer, hotter places, but it just doesn't get cold at night throughout the summer, and for sure, hotter and drier both. For me, one of the things that I have seen, and it isn't what people driving around the park might notice, but maybe they will if they look, is that we've had places where there's an invasive grass called cheatgrass, and it used to just be in patches in the park, and it didn't spread out, it didn't move, and we didn't even worry about it that much because we didn't need to. And I'd say in the last 10, 15 years, but for sure the last 10 years, it's taken over areas down outside of Gardner in the lower elevation. They're just monocultures of cheatgrass. So, and we're starting to see places in higher elevations, which is frightening for me, where it's moving out into native vegetation. And so there are other parts of the country that have seen cheatgrass take over, and there's a couple of reasons why that's something for us to worry about. It not only does it outcompete some of the native vegetation, but it burns. Once it cures up, it takes the moisture early, and once it cures up, it makes it at a high enough density, it can make you really susceptible to a fire. And then lots and lots of cheatgrass seeds, it grows back, you have another fire, and pretty soon the what you see here, the sagebrush and the grasses here, they can't grow back. They can't come back after that kind of a 5-year fire interval or something. And pretty soon you just see cheatgrass everywhere. And that would be a scary thing for me to imagine out across the northern range in the park.
Well, and so that we don't end on a negative note,
Yeah.
is there a, do you have any, what's the outlook, you know, are you kind of feeling, is there something positive that you're looking forward to in the future, you know, as we continue to monitor the climate?
Yeah, that's a tough one.
Yeah.
I do try not to make it so doom and gloom. It's true, and I get that. I think the one thing is a lot of the worst outcomes that potentially could happen, even though we're on a trajectory that they might happen, they haven't happened. There are some of the effects of climate change that are kind of, they call it baked in. I mean, they're already in the atmosphere, and those are the ones we're going to have to figure out how to adapt to. But there's a lot of things that haven't happened, and there's a lot of things that are still up to people, and they're really under our control to keep from happening. And I think on that, you know, that we've got the ability to do something about this.
All right. Well, with that, I'm going to jump back on camera with you over here. I want to thank you for joining in to our next installment of this 150th anniversary virtual video series. I want to thank Ann for joining us today and talking about the past, present, and future of climate change in Yellowstone. And thank you for your support for Yellowstone National Park, and we'll see you on the next video.